Alibaba just dropped something that caught most of the coding world off guard, and honestly, developers are still testing what this actually means. We're talking about Qwen 3 Coder Next. Alright, so Qwen 3 Coder Next just released under Apache 2.0 license, which means you can use it commercially without paying a single dollar. The team behind it is Alibaba's Qwen division, and they have been quietly building one of the strongest open source AI groups in the world over the past year. But this time, they did something different. Instead of going after raw size or massive compute, they focused on three things every coding model struggles with: making it fast enough to actually use in real workflows, smart enough to handle full projects instead of just code snippets, and cheap enough to run locally without needing a data center. When you look at the architecture, it becomes pretty clear why developers are calling this a breakthrough rather than just another model release. The first thing you need to know is the parameter setup. Qwen 3 Coder Next has 80 billion total parameters built into its design, but only 3 billion parameters activate when you feed it a token. That's a mixture of expert architecture pushed to an extreme level. Most MOE models activate somewhere between 10 and 35 billion parameters per token. This one stays under 3 billion, and the performance gap compared to models with 10 to 25 times more active compute is almost non-existent. On SWE-Bench verified, which tests real GitHub bug fixes and measures if the model can write patches that actually pass test, Qwen 3 Coder Next competed directly against DeepSeek v3.2 with 671 billion parameters and GLM 4.7 with 358 billion parameters. This 3 billion active model holds its ground against systems with hundreds of billions of active parameters. That's not a small efficiency gain. That's a complete rethinking of how to build coding models. The second breakthrough sits inside the hybrid attention design. Traditional transformer models suffer from something called quadratic scaling, which means when your context window doubles, the memory and compute cost quadruples. That's why most models hit a wall somewhere between 32,000 and 128,000 tokens. But Qwen 3 Coder Next supports 262,144 tokens natively, which is 256k context, and can stretch to 1 million tokens with extrapolation methods. The way they pull this off is by combining gated delta net with traditional attention in a hybrid pattern. Gated delta net is a linear attention mechanism that scales at ON instead of ON squared, which means doubling context only doubles cost instead of quadrupling it. This hybrid approach keeps the model efficient for long context without losing the ability to understand complex patterns. The result is significantly higher throughput for repository level tasks compared to dense models with similar total capacity. Developers testing it reported that fitting an entire Python library or a full React framework into context feels like working with a 3 billion parameter model in terms of speed, but the understanding stays at the level of an 80 billion parameter system. Now, here is where it gets interesting. This model wasn't trained the way most coding models are trained. Historically, coding models learn from static code text pairs. You feed them billions of lines of code and documentation and they learn patterns. But Qwen 3 Coder Next went through what the team calls agentic training at scale. They built a system called Megaflow, which is a cloud-native setup running on Alibaba Cloud Kubernetes. Inside Megaflow, the team synthesized 800,000 verifiable coding tasks. These weren't simple snippets like write a function that sorts a list. These were real-world bug-fixing scenarios made from GitHub pull requests and paired with fully executable environments. During training, the model interacts with live containerized setups. If it generates code that fails a unit test or crashes a container, it gets immediate feedback through reinforcement learning. This means the model learned to plan, call tools, run tests, and recover from failures instead of just competing against code blocks. And that training shows up clearly in the benchmarks. On SWE-Bench Verified, which uses the SWE agent tool, Qwen 3 Coder Next scored exactly 70.6%. DeepSeek V3.2 with 671 billion parameters scored 70.2%. GLM 4.7 with 358 billion parameters scored 74.2%. So this 3 billion active model is competing directly with systems that have hundreds of billions of active parameters. On SWE-Bench Pro, which is even harder, Qwen 3 Coder Next scored 44.3%, beating DeepSeek V3.2 at 40.9% and GLM 4.7 at 40.6%. On SWE-Bench Multilingual, it reached 62.8%, nearly matching DeepSeek V3.2 at 62.3% and GLM 4.7 at 63.7%. On Terminal Bench 2.0, which tests command line agent workflows, it scored 36.2%. These scores position the model as something that can handle agent-style tasks rather than just autocomplete. The security piece is also worth mentioning because it usually gets ignored. On SecCodeBeans, which measures a model's ability to fix vulnerabilities without breaking functionality, Qwen 3 Coder Next outperformed Claude Opus 4.5 in code generation scenarios. Qwen 3 Coder Next scored 61.2% versus Claude's 52.5%. And on the CW-Evil benchmark, which tests multilingual security, it hit a functional security score of 56.32%, beating both DeepSeek V3.2 and GLM 4.7. What makes this impressive is that the model maintained high scores even when provided with no security hints. That suggests it learned to anticipate common security problems during the 800,000 task training phase rather than relying on explicit prompts. When you are building production systems, this kind of built-in security awareness saves hours of manual review. To be clear, the model has limitations. It only supports non-thinking mode, which means it doesn't generate those long reasoning chains, warping thing tags like some newer models. The official documentation stresses this point. If you need extended reasoning output, you would want a different model. But for agent workflows that already assume direct tool cost and fast responses, this design choice actually helps. The integration becomes simpler because you don't need to parse or stripe hidden reasoning segments. Another limitation is deployment requirements. Running the model locally requires significant RAM or unified memory. We're talking about at least 46 to 48 gigabytes for 4-bit quantized variants and around 85 gigabytes for 8-bit variants based on GZUF specifications. So you are looking at systems with high-end GPUs like dual RTX 4090s or Apple Silicon Macs with 64 GB unified memory minimum for the 4-bit version. The M3 Max or M3 Ultra configurations with 96 GB or 128 GB would handle it more comfortably and support the 8-bit version too. That's not pocket change, but it's still within reach for serious developers and companies. And if you run it on a server with multiple GPUs, ACLang version 0.5.8 or higher and VLLM version 0.15.0 or higher, both supported with OpenAI compatible endpoints. The Unsold guide even shows how to hook Qwen 3 Coder Next into local agents by swiping the model name while reusing the same prompt templates. Now, the model also introduces some clever design choices that show the team thought about real workflows. They built an XML-style tool calling format specifically for coding agents. Traditional JSON-based tool calls struggle when you need to pass long code snippets because of nested quoting and escaping overhead. The new format handles string-heavy arguments cleanly, which matters when you are sending entire functions or files as parameters. The training data was extended to focus on repository-level understanding instead of just file-level datasets. That focus on cross-file dependency logic helps the model understand how changes in one module affect the rest of the codebase. The team even developed specialized approaches during training. For web development tasks like UI construction and component composition, code samples were rendered in playwright-controlled Chromium environments to ensure accuracy. For React samples, they deployed wide servers to verify all dependencies installed correctly. This level of care in training data preparation translates directly into better outputs in real projects. This integration ecosystem is also growing fast. The official model card mentions compatibility with Claude Code, Qwen Code, Coder, Kilo, Drake, Line, and other CLR or IDE platforms. That adaptability comes from the 256K context window and scaffold template flexibility. Developers can plug it into their existing setups without rewriting workflows. SDLang version 0.5.8 or higher supports it with the tool called parser flags set to Qwen 3 coder. VLLM version 0.15.0 or higher works the same way with enable auto tool choice enabled. Both expose an OpenAI compatible endpoint at localhost, which means any tool built for OpenAI's API can switch to Qwen 3 coder next by changing the base URL and model name. That's massive for teams already invested in existing infrastructure because migration becomes trivial. In fairness, we should also talk about what this model doesn't solve. It's not the best model on every single benchmark. Other recent releases like Kimi K2.5 perform compatibility on similar tasks. Larger proprietary models like Claude Opus 4.5 still have advantages on certain complex tasks. Models with extended reasoning modes can handle certain logic-heavy workflows better. But the point isn't that Qwen 3 Coder Mixed beats everything everywhere. The point is that it delivers frontier-level performance with a tiny function of the compute cost compared to much larger models. And for developers who want privacy, control, cost savings, and the ability to run locally, this model changes the equation completely. One commenter captured it well. The question isn't which model scores highest. The question is what can I run locally without needing enterprise grade infrastructure. So that's where we will wrap it up. One thing I'm curious about now is how fast the open source ecosystem will absorb this. We have already seen GGUF quantizations, Llama.cpp support, LM Studio integration, and multiple deployment guides within hours of release. If this pattern continues, we might be looking at a future where the gap between open source and proprietary coding models effectively disappears for most real-world use cases. Drop your thoughts below. Make sure you are subscribed, hit the like button, and I will see you in the next one.